Hello everyone! Today I'm going to be talking to you about your textbook. This is your textbook. You can pick it up. You can download a PDF version for free. That's why we use it. Well, that means you can also take that PDF and print it out at a FedEx Kinko's or on campus without violating any copyright laws. So they'll do that for you since it's not copyrighted. I highly recommend having a physical copy of your book because it's going to make all the difference in the world in how well you do in this course to have a physical copy that you can reference. So what I'm going to do in these little videos is just point out while you're reading through your book the places that you really need to pay attention to for our class. When you open your book, if you don't know anything about physics, you'd want to read Chapter 1, Section 1. It'll tell you all about what physics is and some important history of physics. But for the calculations, what you're going to want to pay attention to is 1.2. You definitely want to read through this whole thing. You want to make sure you understand all of it. Units, prefixes. You don't need to memorize all these prefixes. We'll be using them enough. I'll point out in lecture the important ones, the ones you do have to have memorized. But we'll use them so much you'll know them anyway, hopefully, by the end. And they're ones you probably already know. Let's see. And that's, for Chapter 1, the most important part is that section there. For you guys. We're going to go on in the first lecture and move into Chapter 2. In Chapter 2, in the first lecture, we're going to be talking about displacement. That's here. And the difference between vectors and scalars, that's here. One thing we're going to do in lecture that's a little different than your book is we're going to skip ahead to Chapter 3 for just one concept, like basic vectors in one dimension pretty much. We're going to be covering this before we really start working with position and displacement so that we can use vectors at the very beginning. So in Chapter 2, 2.3, time, velocity, speed, this is very important. Make sure you read through it. You know the differences between speed and velocity. 2.4 talks about acceleration. That's something that's a lot harder to visualize than speed in some respects for somebody who's never really thought about it. So make sure you really understand the difference between velocity and acceleration. We're going to talk about graphing, position versus time, velocity versus time, and acceleration. Those are things you definitely want to have well understood. So within the acceleration section, instantaneous acceleration is good to understand as a concept, but we won't actually be using it very much. In the motion equations for constant acceleration in one dimension, this we're going to use a lot. So this you want to read thoroughly, really understand. And then it goes on to talk about problem-solving techniques. We'll cover that in class, but definitely reading it because maybe they'll describe it slightly different and it'll work better for your understanding. Falling objects, we cover that. Make sure you read through that. And then graphical analysis, this we'll go over as well. We do this a lot in lab, so making sure you understand the graphs is really important in a lab environment. So for the first lecture, we won't get through all of this, but by the end of like the first week and a half or so, we'll have gotten through a fair amount of this and have done some practice problems. The beauty of going through your book and reading it is that as you encounter these example problems, you can attempt them on, you can read the problem after reading the section, cover up the solution, attempt it on your own, see how your solution, if you make progress, matches their solution. Where did you go wrong, or do you have it fully understood? You're okay to move on. It's a great litmus test to see whether or not you are ready to continue on in your reading, or you need to go back and fully and read more to fully understand that section. So there's a lot of stuff in chapter 2 that we're covering that is exactly in the book. And when you're interested in the vectors that we talk about in lecture, we're just doing a brief intro before starting really chapter 2 material, and that is coming from chapter 3, not here, but where they talk about vectors, what a vector is and everything. It's here. I think there's some very brief intro to it back here in chapter 2. I think we go slightly further than that in lecture, so we're kind of like a combination. And then after chapter 2, before we get into chapter 3 fully, we'll finish the rest of that vector discussion so that you fully understand vectors at that point. So that's it for this little video, just to give you some guidelines for reading and help you focus your attention on which parts of each chapter you should look at. So chapter 2, very heavy. When you go back to what I mentioned in chapter 1 to cover, there was really only one section of really important material. I mean, the rest is not important, but when it comes to studying for exams, this is the section to make sure you understand. It's going to infiltrate the rest of all of the material and be used in all of that. So that's the point of these videos, just kind of give you a little guide on what you need to be focusing on as you look to your book. Make sure you're printing out the chapters as we go through your book, the important sections that you need. You have them in a physical copy. You can go back and reference them easily while doing your homework and while studying. And if you have access to alternative books, that's great as well. You just want to make sure you're choosing college physics. The word college indicates that it's an algebra-based book, not a calculus-based book. All right, see you next time.